Hey guys, so today we are going to look at our notes for reflections. So we're still in our first unit, which is transformations and congruence, and we are looking at moving different shapes on a coordinate plane and the different ways that you can move them. So here you'll see the picture of our table of contents. The first 2 pages of your notes were translations and translations examples. So today we are going to be pasting in the reflection notes and reflection examples, which you guys are going to label page 3 and page 4. So if you need to pause here, you can, as always. If at any time you need to pause the video to write something down, if you're just going at a different pace than me, that's totally fine. Feel free to pause the video whenever you need. So you should have 4 pages after today in your notes. So we're going to start on page 3. I'm going to go ahead and flip to that. And you'll see your reflection notes. Now I have copied blank sheets on your Google Classroom for today. So if you want to open that up and print those out, you can glue those in. If you don't have a way to print those, you can just write your notes. You can write reflections, you can write the definition, you can try to draw this if you want. As long as the information is there, if you don't have a way to print that, you can handwrite it, and that's fine. So I'm going to go through reflections, what it means, how we do them on a graph, and some examples with you. And then I have a worksheet for you to do today. So a reflection is a type of transformation that uses a line that's going to mirror our image. And so it's the exact same thing, but it's kind of flipped over a specific line. And there's different lines that we can reflect over. Typically it's the X and the Y axis. So I'm going to show you the first 2 examples. So the definition is a reflection is a transformation that uses a line like a mirror to reflect an image. So you see our smiley face here. We flipped it upside down across our x-axis. So this horizontal line is the x-axis. In our previous notes, the smiley face had moved. It was still facing up and we had slid it across. And this time we have flipped it. So if it is reflected over the x-axis, all of the points that you have originally, you're going to change them to x negative y. So you're basically changing the sign of that y value. So let's look at the shape they gave us here, this image right here. Remember, before you move an image, it's the pre-image. After it's been transformed in some way, it's the image. And we notate that with the letters for each point, and then the letters prime once it's been moved. So let's look at point T. T is right here. Let's find what that ordered pair is. So that's -1, 2. R is 1, 2, 3, 1, 2, 3, 4. 3, 4. Remember, X comes first, then Y. So we move left and right, then we move up and down. And for the last one, it's over 2, up 2. So that's going to be 2, 2. So these are the values for those points. You will find these points at this ordered pair. Now, if we want to reflect it across the x-axis, what we need to do is change those y values into negatives, or the opposite of what they are. So we see up here x negative y. So we're going to rewrite our ordered pairs. So this would be -1, -2, 3, -4, and 2, -2. So now let's plot these points and see if that's going to give us a true reflection over that x-axis. So I have -1, -2, that's T prime. I have 3, -4, that's R prime. And then I have 2, -2, and that's Y prime. So when I connect these dots, this is always the hardest for me to draw straight lines. It should look like a mirror image across this line, and it does. If we folded this graph right here on this x-axis, and we folded both sides up, they would literally meet and be exactly the same, just like if you were looking at yourself in a mirror. So if we reflect on the y-axis, it should, instead of flipping horizontally and squeezing the paper this way, if we were to fold the paper in half on the y-axis right here and bend each side up until it touches, they should be sitting in the exact same spot. So let's see how that looks. So this is reflection on the y-axis. If your point is x, y, when we reflect it across the y-axis, the image is now going to be negative x, y. So when we reflect across the x-axis, the x stays the same, and the y value is the one that changes. So what you can remember is x stays the same. So if it's a reflection across the x-axis, the x is going to stay the same. If it's a reflection across the y-axis, the y stays the same. So if you can't ever remember which one you flip, just remember if it's the axis you're flipping on, that value doesn't change. So let's plot these points. I'm going to use a different color this time. T is -1, 2. R is 1, 2, 3, 1, 2, 3, 4, 3, 4, and Y is 2, 2. Same points. Now, our reflection is across the y-axis. So when we rewrite these ordered pairs, we need to make our x value negative, or opposite of what it would be here. So here, if it's positive, they're going to change it to a negative. Now that doesn't mean if it's negative, it just stays negative, because then nothing changes. So if it is a negative, we're going to make it positive. So we're going to do opposite of what it started as. So that would be 1, 2, -3, 4, -2, 2. So these that were positive became negatives. This one that was negative became positive. So let's graph it and let's see. So we have 1, 2, and that's T prime. We have -3, 4, that's R prime. And then we have -2, +2, and that's Y prime. So when we connect these, you'll see it's now literally mirrored on the other side. Now, because we've crossed the y-axis, the part that's hanging over on this side, when we mirror it, the same amount should be hanging back over to the other side. So I don't want that to freak you out. It's still mirrored, even though they're crossing each other, because we're flipping it on an axis that is crossing over itself. So of course its mirror image should also cross. So the second page here is 2 more examples. However, this time we're going to cross over the y equals x line, or the y equals -x line. So y equals x means it's a line that crosses right here through the origin, meaning whatever y is, x is. So if x is 0, y is 0. If x is 1, y is 1. If x is 2, y is 2. If x is 3, y is 3. And so you'll end up having a line that goes straight through the middle. Just like that. So that is the y equals x line, right? If you were to plug any number in here for y, it has to equal the same number, or else it's mathematically not true. So whatever y is, it will equal that same thing for x. So if y is 2, x is 2. If y is 1,000, x is 1,000. And so no matter how far you go over, you'll go the same distance up, and you'll end up creating this linear line here. So we can reflect across that line as well, and there's a rule that we remember for that. We just flip our ordered pair. So if your line is y equals x, whatever your ordered pair started as for the pre-image, just flip that ordered pair and you'll get your new coordinates. So again, I think these are the same points, -1, 2, 2, 2, and 3, 1, 2, 3, 4, 3, 4. They are. So if we're reflecting across the y equals x line, that's a different reflection than before, than the 2 previous pages. We are going to flip. So I want you to up here just to write flip. Okay? we're going to flip our ordered pair. It's now going to be 2, -1, 4, 3, and 2, 2. And always, if you're, questioning yourself and you're not sure if you've done the right trick and you've reflected it across the proper line, when you go to graph this on your paper, if you fold the paper at the reflection line, they should touch and be in the exact same spot. So if you reflect this and it's all the way down here in this quadrant, and you were to fold this paper up, if they're not going to touch each other and be each other's exact mirror image, then you've done something wrong. So you can always graph it and double check your work. So if we plot these points now, we have 2, -1, 1, 2, 3, 4, 3, and 2, 2, which is right there. So let's see, 2, -1 was T, this was R, and that's Y again. So if I folded this on this line, those would touch. So it looks right to me. Now I want to leave this last one empty for you guys to do so that I know that you copied your notes down. I'll get you started and show you where the line needs to be that you're reflecting over, but I want you to fill in the pre-image points. Hint, hint, it's the same points we've been doing this entire time. And I want you to write down what the new ones will be if you reflect across that line using this trick. So if it's reflected over the line y equals -x, so when we just did this one up here, we looked at this, y equals x, that was a linear function, right? It had a slope of up 1 over 1, up 1 over 1. This, even though it doesn't look like it, could be written in slope-intercept form. All you'd have to do is put an imaginary 1 in front of this. There you have the y equals mx. And you could put plus 0 at the end for your b value, since we did start at 0 on the y-axis. So you could put it in that form to help you see, but this is a linear function. Is it a function? It passes the vertical line test. Does it have a slope? It does. It's not a straight up and down or a horizontal line. So this is a linear function. Now to make that a negative function, you put a negative sign in front of it. So basically it's going to start at 0 again, but now it has a slope of -1 over 1, down 1 over 1, down 1 over 1, down 1 over. So this is the line that you're reflecting across now. So we flipped it. We made it a negative slope. So if this is the line you're flipping across, this image needs to be reflected over here. And the rule is -y, -x. So not only do you flip, but you flip and change signs. So I'm just writing that down. Flip and change signs. Okay? So whatever these 3 points are, and you've written them down here, your new ones, when you reflect, need to be flipped. So the y needs to come first and then the x. You also need to change their sign. So if it was a negative before, it should be a positive. If it was a positive before, it should be a negative. This does not necessarily mean they have to be just negative. This is just showing if they started this way, your answer will be flipped and changed signs. Okay, so this is how we reflect. Reflections should be mirror images. They should be in the exact same spot if you were to fold that graph at that line and have those papers touching. So I'm going to leave this blank and I want you guys to fill it out. That's all I want you to do for your notes today. And then the worksheet that I uploaded is called Reflection Practice. I thought it was really cool. So there is a fish that is drawn on this graph here. And each point for this fish is labeled A, B, C, D, E, and F. Okay, A, B, C, D, E, and F. Every point is there. You can see what that point is. You can find the ordered pair using your axes. So down here for number 1, it says, in the table below, write the coordinates of the figure above. So for every single point, I want you to tell me what is the ordered pair for A? What are the coordinates for A? What are the coordinates for B? And give me those. So you'll come up here and you'll plot them. Remember, X comes first, which is left and right, then Y. I've noticed some of you guys will move up and then over to your point, and you'll write it down that way. And that's not how we write ordered pairs. You need to move left or right, then up or down to get to your point. So you're going to do that for all of the points to start with. And then it wants you to reflect across the y-axis. So that's this axis that has a big Y on top of it, which means you need to take this fish and flip this fish over to this side. And if you can't remember the rule that you do, it is in your notes. What do you do when you reflect across the y-axis? There's something you do to your coordinates. And then you'll write the new ones right here beside each letter primed, A prime, B prime, C prime. And it's going to ask you to compare them. What do you notice? And then it wants you to count how many blocks each point is from the y-axis. So the original A from this y-axis, A is 2 blocks away. Like from A, if I just walk straight over to get to the y-axis, it takes me 2 steps. Now what it's going to ask you is when you're looking at your new A prime, which will be somewhere in this graph, how far does it take you to get back to that y-axis? So you're going to answer that for all of these. How many steps is A from the y-axis? 2. How many is B from the y-axis? How many is C from the y-axis? How many is D from the y-axis? So from all of these points, the only thing you're doing is counting over until you get to the y-axis. I don't need to know how far up you are, just how far you are from the y-axis, directly straight across. And then the last question it asks is the distance from the mirror line to any point on the figure is greater than, less than, or equal to the distance from the mirror line to its reflected image. So think about that, answer that properly, and that's your worksheet for today. So not only do you have to fill these notes out and finish that last question, but I want you to get this worksheet completed as well. Good luck, guys.